So welcome back, students. Now I'm going to teach you the most important and picked up and most relevant questions for your NEET examination from the P block chapter, right? So P block basically is very, a very lengthy chapter in NCERT. I try to pick up all the important questions which will be very useful for your NEET examination. Let us solve. I've given in the form of a fill in the blank, so that option would be easy for you to remember, right? So when I start with group 13, P block, we very well know it starts with group 13, 14, 15, 16, 17 and 18, isn't it? Right? Fine. So 3A group basically. Now, so let us read the first question. What is this? Most abundant elements. So most abundant element in group 13. What is the first most abundant element? First is oxygen. Next abundant element is silicon. Next abundant element is aluminium. Right. Now, so most abundant metal. Right. So here this is elements. So the most abundant metal among all these three is aluminium. So remember. So the option would be carefully. Abundant element is this. Most abundant metal is aluminium. Right. Next question. How does boron exist? Basically, boron in nature, how does it exist? Means it exists in the form of borax. So remember this option. Next question. Why is the radius of gallium nearly equal to that of aluminium? Right. So why is the radius of gallium? Basically, when we learn, we have studied, isn't it? Like left to right in the periodic table, size decreases. From top to bottom, size increases, isn't it? Because of the addition of number of shells. But here they said radius of gallium is nearly equal to aluminium. Why? Because d electron in gallium does not contain or does not screen nuclear charge effectively. That is the main thing. Because of the ineffective shielding of that particular thing, the size of the radius is equal. Let us write the reason. What is the radius? They may ask you which is a relevant reason of gallium having radius equal to aluminium. So reason would be d electron of gallium does not screen nuclear charge. That is the first thing. This would be one of the reasons effectively. Next, outermost electron, it experiences more force of attraction because it does not shield, isn't it? So the outermost electron, whatever is there in the outermost shell, it starts experiencing more of nuclear attraction and causing decrease in radius. So next thing is outermost electron experiences pull. Correct? Experiences pull. What will happen then? Automatically the radius or the radius of that particular thing decreases. Radius decreases. That's why both are equal. Done. Now next question. Why does boron have high melting point? What is the reason? Main reason is this one. It exists as giant covalent polymer. Why does it? Because high melting point, because the main reason is it exists as giant covalent polymer. Which state? Basically in both solid state and liquid state. That is the reason it has high melting point. It exists in the form of a covalent bond, isn't it? So in which one? That too, giant covalent bond, giant molecule. That's the reason the melting point is very, very high. Let us read the next question. Okay. Element used in high temperature thermometry. Okay, they may ask you in thermometry what is the element used? Basically the answer is gallium. Why? Its melting point is 30 degree. 30 degree it exists as liquid, means this gallium, why it is used means it from the melting point from 30 degree till 2000 degree it exists as liquid. That is the reason I use gallium in thermometry. Right. Now next question. Which element shows +1 and +3 oxidation states and why? So basically in the group 13, the element, the common oxidation state is +3, but still we have +1 and +3. Which elements show? Means elements like gallium, indium and Tl. These three show +1 and +3 oxidation state, right? Yes, students. Now, order of +3 oxidation state. And why also I asked. So remember, gallium, indium, thallium, they exhibit +1 and +3 oxidation state. What is the reason? Basically due to inert pair effect. So inert pair effect, I already did a video. So inert pair effect is, what is inert pair effect? Please watch that. So the option, if they ask you +1 and +3 oxidation statements, you can write gallium, indium and TL. So basically plus 3 is common, but among these they also show plus 1. Now they've asked here order of plus 3 oxidation state. So let us write boron maximum, aluminium, then gallium, then indium, right? So remember this order, students. Next one. They've asked us order of plus 1 oxidation state. Just see here, boron will be less, it shows plus 3 basically, boron less than aluminium, less than Ga, less than indium, less than TL. Okay, fine. So next, students, hope you're understanding. I'm going a little bit faster. Any doubt, please keep it or send it in the comment section, right? So don't get confused, students, and don't get panic for the exam. Everything will be fine. You'll do it very well. Don't just relax yourself. When you relax yourself, miracles will happen. Okay, right, let us come back and see the next question. That is, among group 13 elements which show oxidizing property, right? So among group 13 element option which show oxidizing property, basically the element is TL, right? So TL is this one because TL exists as plus 3. We have written, see here, plus 3. So what does it do? From plus 3 state, it gets converted to TL plus 1 state. So isn't it oxidizing property? Yes. So this is the reason. So question again, among group 13 elements which show oxidizing property means tellurium, because thallium, because thallium, it converts from plus 3 state to plus 1 state. So boron, among boron, aluminium, gallium, indium and thallium converts from plus 3 to plus 1 state. That's why it shows oxidizing property. Next question, which element shows plus 2 oxidation state, right? So plus 2 oxidation state element is gallium. Remember this option. In which one it is showing plus 2 oxidation state? Basically it's going to show in GaCl2. In this compound it's going to show plus 2. So plus 2 plus 1 is here, plus 3 is plus 2 is here, plus 3 is here, plus 1 plus 2 plus 3. Done. So these are the different things. Let us see one more question. They've asked, bonding in compounds of 3A is covalent due to. Why is the bonding in compound in 3 covalent? Why is it forming covalent bond? Basically, the characters which depend on the covalent nature is small size. When the size is small, polarizing power will be more, isn't it? Right? Now, that is one reason. Next, ionization energy is high. Second thing, this reason also it accounts for the covalent nature. Next, third reason, electronegativity is high, very high. That's the reason it shows covalent character. So these factors, they give you as an option. You can mark all these characters, all these factors, they affect or they form or they basically are important to show or for a compound, for this one to form a covalent bond. We have seen one covalent compound, isn't it, just now? Right. Now let's see what is which element is ionic in nature in group 13. The element which is ionic in group 13 is thallium. Remember this, students. Next question. Which element forms metal ions in solution and why? Right? Which element forms metal ion in solution and why? Let's see. The element which forms metal ion in solution is aluminium, gallium, indium and thallium. All these, they form ions in metal ions in solution when you just dissolve. Right. Next question. Why do group 3A element form complexes much more readily than S block? So what is the reason for forming complexes? So for complex formation, as we have seen for covalent bond, for complex formation, the characters are, so if it is small, because of the small size, right? And after that, new increased charge. Small size means drag the electron density. So next concept is increased charge. Next concept after this, vacant d orbitals. Vacant d orbitals. So these are the characters to which it means it is allowing it more, it's able to form complexes because of these characters. Next question, student. 16th question. Which is a more reactive, boron or finely divided boron? Basically, whichever is finely divided, always remember it is more reactive. Why? Because the surface area will be more. Finely divided, surface area will be more. So here among these two, boron is it is non-reactive, but finely divided boron is more reactive. Why? What is more reactive? Oxide of boron is more reactive, that is finely divided. So finely divided by, as I told you just now, surface area is more. Next question, which oxide is used for anodizing? Which oxide? We very well know anodizing process. I did one video also on anodizing process. So answer is oxide film of aluminium. Remember this. Next, effect of water on group 3 elements or 13th. So basically when I take boron, first remember boron is not affected by water. Okay, not affected by either water or steam. Next, aluminium. Aluminium, what does it do? Whenever it decomposes in cold water only, but if the oxide layer is not present in its surface. So remember, if oxide layer is not present, it will decompose in cold water. Done. Next, when it comes to gallium and indium, gallium and indium, basically they are attacked by water only in the presence of oxygen. Remember, gallium and indium are attacked by water only in presence of oxygen. Remember, so boron does not react, aluminium decomposes in cold water, gallium and indium, and that too it decomposes when an oxide layer is not present. That's important. Next one, gallium and indium, when will they be attacked by water? Only in the presence of oxygen. Right. Now let us see the next question, students. So when it comes to the next question, what is this? Which element becomes passive with concentrated nitric acid? So the element which becomes passive with concentrated nitric acid is aluminium and gallium. Remember, not boron, indium or thallium. Done. Next, which gas evolves when boron, aluminium and gallium react with alkali solutions? Okay, right. So alkali solutions basically, base dissolved in water, but most of the students they get confused when you go to the lab. Alkali solutions, alkaline solutions. Okay, so what should we remember? Alkali solutions means most important, as I told you just now. Sorry students, alkali solutions is what? It's a base that dissolves in water, right? Means a soluble base which has pH greater than 7. That's all, right? So in alkali solutions, which gas evolves when they dissolve in alkali solutions? Means hydrogen gas. Remember that. Next, which gas? Same question. Which gas evolves when indium, thallium reacts with alkali solutions? So boron, aluminium, gallium, when they react with alkali solutions, they give hydrogen gas. When indium and thallium, when they react with alkali solutions, remember this, no reaction at all. In the exam, if they give you an option, hydrogen gas, which one? Means boron, aluminium and gallium, but indium and thallium, no. Reaction is no. Right. What is the nature of oxides of group 13? Okay, so B2O3, aluminium oxide, gallium oxide, trioxide, indium trioxide, thallium trioxide. So B2O3 nature is acidic in nature. Remember. Next, Al2O3 and Ga2O3 are amphoteric in nature. Amphoteric. These two are basic in nature. Remember this question. So let us come back to see the next question, students. What are the hydrides of group 13? This is what is one more question which is given, right? Hydrides of group 13. Basically, we have seen oxides, hydrides, what do you see, metal hydrides, isn't it? When you go to group 14, carbides, that also we'll see. Let's come back. Here in hydrides of group 13, basically it's a combination of the metal with hydrogen, correct? Now, so in hydrides of first element, BH3. BH3 is what? It is unknown, basically. Now, next hydride of group 13, ALH3. What is the name of this? This is called alane. Next one, Ga2H6. What is this called? Digalane. Remember this for the option. Let me write here. Iron, indium. What type of hydride it forms? It forms polymeric hydride. Remember this. Next one, tellurium. It does not form hydride. So if they ask you which among the following is the hydride of tellurium, it does not form any hydride. Remember that. Next important, anionic hydrides of group 13. So anionic hydrides are the reducing agents, sodium borohydride, lithium aluminium hydride. All these are reducing agent which we'll be using in organic chemistry, isn't it? Right. Next is the last one, lithium gallium hydride. All these four are anionic hydrides. These are the general hydrides, these are the anionic hydrides. Right. Now next one, let us come back to next. Which is a colorless gas when lithium aluminum hydride reacts with BCl3. Okay, which is the colorless gas, that's it. So basically the colorless gas which evolves when the reducing agent reacts with boron trichloride is diborane. Remember this colorless gas. What is this? What is the formula? B2H6. Right. Next question, give the products of the following. So diborane, when it reacts with ammonia, first important thing, it's going to form B2H6.NH3. Then when I heat this compound to 200 degrees, it's going to form a compound. The name of the compound is called borazole, or it is also called inorganic benzene. Inorganic benzene. What is the name of this compound? Basically this is B3N3H6. Remember this. Borazole or inorganic benzene is B3N3H6. Right. Let us see one more question. Next question, almost as I promised you, 70 questions I'll be doing, students. So don't read carefully, all will be covered in this. Right. Now, relative Lewis acid character of boron trihalides. So boron trihalides means basically boron X3. This is what is asked. They asked relative acid character. So when I come back, so what is the order? Bi3 is greater than BBr3, it is greater than BCl3, it is greater than BF3. Remember this order, students. So the Lewis acid character of boron trihalides is this. Why? Because due to back donation of smaller halogen atoms. So why is this order seen? Because of back donation by smaller halogen atoms or smaller halogen atoms, isn't it? So this is a smaller halogen atom, and they start back donating to boron like this. It back donates to this, forming what type of bond they form? They form p-pi bonding. Okay, so because of this back donation, the order is formed. So let us write due to what? Back donation of boron, back donation of halogens. Right, let us come back. Draw the auto complex of AlCl3. Okay, AlCl3 is a Lewis acid, we very well know, isn't it? So what is the thing now? They've asked us to draw the complex. Let us draw Cl here, aluminium, Cl, chlorine. This donates to aluminium, Cl and Cl. Basically anhydrous form of aluminium. What anhydrous form is covalent, right? So remember, anhydrous form of aluminium chloride is covalent. But if it is hydrous form is always ionic in nature. What is the formula of this? This is nothing but AlCl3.6H2O. Remember this. Anhydrous form is covalent, hydrous form is ionic in nature with this formula. Right, next question. 17th abundant element in nature, carbon. Second abundant element in nature, silicon. Right, remember. Next question. Non-metallic nature. Okay, among group 14, we have come to group 14 now, no? Among group 14, carbon and silicon are non-metals. Germanium is what? It is a metalloid. Tin and lead, what are they? They are metals. This is one question. Yes, right. So almost 30 questions we have completed, very important questions. Let's start off with the 31st question, student. Right, let me turn my page. Now, next 31st question. Among the following, which is a better reducing agent? Okay. Now, among group 14 elements, which is a better reducing agent? Basically, among group 14, we have group 14 elements. Among that, what is a better reducing agent? They said. So, basically, I'll directly write the answer. It is germanium +2 and SN+2. Remember, why? Because stability of M+2, that is germanium +2, SN+2, it increases. Stability of +2 state, that is M+2 state, it increases when the atomic number increases. As the atomic number increases, stability of +2 state increases. That's why they act as reducing agents. Now, when we learn reducing agent, we have to learn about oxidizing agents also, isn't it? So which is a better oxidizing agent among that? Basically, better oxidizing agent is Pb+2. Reducing agent is Je+2 and Sn+2. Oxidizing agent is Pb+2. Why? Because Pb+2 is more stable than Pb+4. That is the reason it acts as an oxidizing agent. Hope you understand the concept of oxidizing agent and reducing agent, students. Right. Now, next question. Reason for high catenation property of carbon. So basically, we very well know self-linking property of carbon, isn't it? What is the reason? Basically, for showing catenation property, when catenation concept is given, first important thing which you have to remember is high bond energy. High bond energy. This is the main important thing between carbon and carbon. If high bond energy is there between carbon and carbon, they show catenation property. Let us see. If it is a bond between carbon and carbon, the bond energy is 83 kilocalories per mole. If it is between carbon and oxygen, 86 kilocalories. If it is between your carbon and chlorine, it is 81 kilocalories per mole. Right? So if there is high bond energy, automatically they show catenation property. Right. Next question. Which element of group 14 does not show allotropy? So obviously lead. Lead does not show allotropy. Done. Next. What are the allotropes of group 14 elements? Okay, let us write all the allotropes. Carbon. So carbon shows what? Carbon allotrope is diamond. Carbon allotrope is graphite. Carbon allotrope is coal charcoal. Okay. Carbon allotrope is lamp black. Carbon allotrope is fullerene. Fullerene, right? This is so many allotropes are there. When it comes to silica, silica basically shows two types of allotrope. One is crystalline form, one is amorphous form. When it comes to germanium, germanium it shows two crystalline forms. When it comes to tin, it's going to show gray, white and rhombic forms. Gray, white and rhombic forms. Remember this. So these are the allotropes of these elements. Let us see next question, students. Yeah. So let me turn the page. Yeah. 36th question. What do they give me? Product formed when carbon reacts with fluorine at 700 degrees. So carbon is reacting with fluorine. It's going to form a compound called CF4. CF4 at 700 degrees centigrade. CF4. Let us balance 2. So this is a reaction. Next. What is black lead or plumbago? So such questions I've already seen. So you'll be getting certain questions with terminology. So what is black lead or plumbago? It is nothing but graphite. Remember this. Graphite is nothing but black lead or plumbago. Next, what is graphite acid? Right. So graphite acid is basically formula is C11H4O5 graphite acid. How did I get this? What happens is when you treat graphite with alkaline cheminophore, okay, it gets oxidized to a compound that is C6COOH taken 6 times. Now what do? I'm going to let's take this and I'll allow it to react with oxalic acid and along with this I get this compound as well as oxalic acid. Okay, HCOH. What do? I'm going to take this one and I treat it with concentrated nitric acid or concentrated sulfuric acid. Then I'm going to get this graphite acid. Right. So when you treat this, basically this compound oxidizes to form graphite acid. So graphite acid, once again, what we are going to do? We are going to take graphite. We are going to treat it with alkaline cheminophore. What will happen? We are going to get this compound. This further it oxidizes when I treat this with concentrated nitric acid or concentrated sulfuric acid. What acid do I get? Graphite acid. Right. Next question. Which material is used in making electrodes, refractory crucibles, moderator in nuclear reactors, lubricants in machinery? Basically, why did I give this question? Because application based or applications, they'll give you the uses, they ask you to find the correct element. So Graphite is the element which is used in all these. Okay, remember this. Next question. Let us see the next question. 40th question. Order of thermal stability of group 14. Okay, thermal stability. How do they respond to heat? So order is CX4 greater than SiX4 greater than GX4 greater than SNX4 greater than PBX4. Right, so this is the order of thermal stability. Remember. Next, in group 14, what is a poisonous gas? So basically, carbon is the first element. So carbon monoxide. But poisonous gas means, why I'm saying this? Because when it reacts with hemoglobin, it's going to form what? Carboxyhemoglobin, which it does not have the capability or capacity, you know, to absorb oxygen, right? So this particular thing, this back bonding means pi acid ligand. What is this called? Pi acid ligand. So because of this formation of oxyhemoglobin, because there is no absorption of oxygen, that's why it is called as a poisonous gas. If they ask you poisonous gas is, you can just write carbon monoxide because of the formation of oxyhemoglobin. Next, what is carbogen? So such questions are quite common in entrance exams. Carbogen is a combination of oxygen, which is 5% to 10%, and it is a combination of carbon dioxide. Remember. Next, and also it is used as where is carbogen used? Basically, it is used in artificial respiration. We call it as carbogen. The composition is 5% to 10% oxygen, carbon dioxide. So used in artificial respiration. Right. Remember. Next, dry powder extinguishers. What is dry powder extinguisher? Basically, it is a combination of sand and baking soda. Remember. Next, fomite extinguishers. Fomite extinguishers is a combination of aluminium sulfate and sodium bicarbonate. Right. What are the carbides of group 14? So basically, carbides of group 14, what are the different things? They form salt-like or electrovalent carbides. Methanides, let us write all carbides of group 14 are like salt-like carbides or electrovalent. Then they form methanides. They are also going to form acetylides. They are going to form aldehydes. They are going to form covalent carbides. They are going to form metallic or interstitial carbides. So this is the different carbides which we have. So one is salt like or electrovalent, methanides, acetylides, aldehydes, covalent and metallic and interstitial. Let us turn the page, students. Let us come back and do the 46th question. Right. So etching of glass. So basically this is quite common question. Etching of glass. So etching of glass, when do we call this? Whenever a glass is attacked, means etching of glass is nothing but, remember, attack of glass by HF. When it is attacked by HF, it's going to silica is going to form silicones which are covalent which has a covalent network, and finally. Right. So let's come back and see the group 48 means question 48 students. So metallic nature of group 15, nitrogen and phosphorus are non-metals, arsenic and antimony are metalloids, bismuth is a metal. Now acidic nature of group 15. So basically acidic nature, when I see the group 15 oxides, what are the different oxides? N2O3 is 1, P2O3 is 1. So this is acidic in nature. Next, AS2O3 and Sb2O3 are amphoteric in nature. Amphoteric. Next, BiO3 is basic in nature. So they have asked acidic nature, isn't it? So first two are acidic in nature, next are amphoteric in nature, next are basic in nature. Right. So when I have to see the acidic nature, if I have to see the order of this, so remember N2O5, P2O5, AS2O5, SbO5, Bi2O5. So when I move from here, remember from left to right, acidic character decreases. Remember this. Okay, so oxides of this particular group 15, all these, as I move from left to right, means sorry, if I have to move from top to bottom, right? So top to bottom, the elements, the acidic character decreases as the size increases. Let us come back to the 50th question. They've asked us, what are oxyacids of nitrogen? Very important. Nitrogen, it forms the first oxyacid, that is H2N2O2. What is this called? Nitrous acid. Next one, H2N2O4. What is the name of this oxyacid? Nitrocyclic. HNO2, nitrous acid. HNO3, nitric acid. HNO4, peroxynitric acid. Okay, right. So remember, students, these are the oxyacids. What are the oxyacids of phosphorus? They ask, because oxyacids are quite common, important thing, isn't it? Let us write the oxyacids of phosphorus. H3PO2. What is the name of this? It is called hypophosphorus acid. Next one, H3PO3, phosphorus acid. H3PO4, orthophosphorus acid. HPO3, metaphosphoric acid. H4P2O7, pyrophosphoric acid. Right, students? Hypophosphorus acid, phosphorus acid, orthophosphorus acid, metaphosphoric acid, and pyrophosphoric acid. Right. So for the same thing, they've been asking the basicity. Right, so remember, basicity, basically the number of OH bonds formed, isn't it? Right, here for H3PO3 basicity is 1, for this basicity is 2, for this basicity is 3, for this 1, again for this basicity is 4, for H4P2O7, that is pyrophosphoric acid, basicity is again 4. Done. Let us see the next question. So Nessler's reagent. What is Nessler's reagent? It is nothing but potassium mercuric iodide, isn't it? You have done in your salt analysis also. We'll be testing using this Nessler's reagent also. Right. Next, what is iodide at million space? Millon space. So this is not millions, it is Millon space. Iodide of Millon space is nothing but H2N HgO HgI. This is iodide of Millon space. Remember the formula. Next, laughing gas. We very well know the simplest one. Laughing gas is N2, isn't it? I've picked up the genuine ones from the textbook. So every question or every line of NCERT is included in this. Next, what is aqua regia? Aqua regia contains 3 parts of concentrated HCl and concentrated nitric acid. Remember this. This is aqua regia. Next, which one is used as rat poison? Okay, radioactive phosphorus. So radioactive phosphorus is used as rat poison. Remember, right? Next, used in treatment of leukemia, making incendiary bombs and smoke screens. So which is the element used in treatment of leukemia? Right. So treatment, okay, basically I'm sorry, this is radioactive phosphorus. I'm sorry students, this is radioactive phosphorus, treatment of leukemia. Here which is used as rat poisonous, I'm really sorry, it is yellow phosphorus. So yellow phosphorus is used as a rat, used in one of the ingredient in rat poison. Done. Let us see question number 59. Rocket fuel. What does rocket fuel contain? It contains mixture of ozone and it contains cyanogen. Remember, rocket fuel, mixture of ozone and cyanogen. Gunpowder. What is gunpowder? What does it contain? Basically, it's mixture of sulfur, charcoal and potassium nitrate. KNO3. Remember. Next question. They are used in vulcanization of rubber. Basically, in vulcanization of rubber to form, which we'll be using sulfur bridges. It will strengthen this. Basically, 4% sulfur is very important, isn't it? Right. So, what is that? Basically, it is used in sulfur. It is S2Cl2. This is used in vulcanization of rubber to increase the strength of that rubber. Now, next question. As electronegativity decreases, acidic character, what will happen to the acidic character? Dash, and what is the order? Remember, always as electronegativity decreases, acidic character also decreases, remember. Okay, right. As electronegativity decreases, acidic character decreases. Let us see the order. HClO4 greater than HbRO4 greater than HiO4. Now see here, among all these, which is more electronegative? Right? So basically highly electronegative is fluorine. Which is least electronegative? Fluorine, chlorine, bromine, iodine. See here. Now iodine electronegativity is very less, correct? So the acidic character also is less. Lesser the electronegativity, lesser is the acidic character. Done. As the oxidation number increases, what will happen to the acidic character? Remember, as the oxidation number increases, acidic character increases. Both are directly related. What is the order? HClO less than HClO2 less than HClO3 less than HClO4. This is the order. So as electronegativity decreases, acidic character decreases. Oxidation number increases, acidic character increases. Remember that, right? Next, what are the products of the following? Okay, see here, this is really quite common question. Fluorine, when it reacts with cold and dilute, basically you have cold and dilute, you have concentrated, isn't it? Right. So when fluorine reacts with cold and dilute, the products formed are NaF plus OF2 plus H2O. Balance it, 2, 2 and 2. Remember this, OF2 is a product. Next, suppose if you are treating fluorine with concentrated nitric acid, so the product formed is NaF plus oxygen and H2O. Let me balance, 2, 4, here 4 and here 2. For dilute you are getting OF2, for concentrated you get oxygen. Remember that. Yes students, right. Next one, if you treat any halogen with cold sodium hydroxide, what do you get? NaX plus NaXO plus water. Okay, 2. Right. What is the name of this NaXO? This is called hypohalite. Suppose if I am dealing the same halogen with hot and concentrated, same product, I get NaX, but here this will change, NaXO3 plus water. So if I have to balance this, 3, this is 6, this is 5, this is 3. What is the name of this one? This is called halite. So when you treat it with cold and dilute, you get hypohalite. When you treat it with hot and concentrated, you get halite. Next question students, they are asking you what is euchlorine. Okay, I think NCERT this is not there. So basically euchlorine is, you know, we call this when we are warming potassium chlorate with concentrated HCl. So when we treat potassium chlorate with concentrated HCl, what happens? It gives a mixture of chlorine and ClO2. Okay, this combination, this mixture is called as euchlorine, and this is used where? This is used in the bleaching agent. It is used as bleaching agent. So what is euchlorine means? This is a concept, right? So next question, 66th question. Dash is used in inflating tires of big aeroplanes. So what is the thing inflating tires? It's nothing but helium. Dash is used as welding, fluorescent tubes, incandescent lamps, metal filament. Basically whenever you see welding, argon. It's used as cryogenic, right? So liquid helium. It is used in advertising, means very shiny glowing boards. Where is it used? Means neon. Dash is used in radiotherapy of cancer, radons. Such applications of inert gases are very important in your exam students. Next one, what is the composition of gases used in by sea divers and asthma patient? Okay, whenever sea divers are there, what is the composition of gas they use in the cylinders? That is what they're asking. So composition is, remember, 80% helium, 20% oxygen. So instead of ordinary oxygen, to prevent the bends, they're going to use these two combinations. Let us see the 68th question. Next, spring water. Okay, what is spring water means? Nothing. Spring water is nothing but water, okay, dissolved helium. Basically, spring water is nothing but dissolved helium, neon and argon. This is spring water, right? Next, if they give you such reaction, this is very important reaction, radon, it combines with Okay, radon, what happened when it decomposes? It decomposes into alpha particle. Now already in 226 4 are over. How many are left? 2, 2, 2, 88, 2 are over. So this is 86. So 222 plus 4 is 226. 86 plus 2 is 88. This is a dissociation. Last question, students. Natural gas contains, what does it contain? It contains 7% of helium. What is that thing? On natural gas, if they ask you composition of natural gas, 7% of helium. Right, students? So this is from my side. I have picked up 70 questions of your P block. Very important questions, right? After my whole day work, I thought I have to send you. I'm sorry I'm late, but all the best, students. Stay confident. You will win in your NEET examination. All the best from my side. God bless you all. Stay connected.